Hi everyone, this is my son and welcome to my channel Hassan Academy. So today I have selected three questions that's very important for JEE or Neet. Okay, these are important questions, all are important questions. So let's discuss all these three questions. And before I am solving it, you pause the video and try to find out your own answer so that you can match or you can check whether you know all this or not. Okay, let's discuss methyl bromide and they have given nucleophile. Okay, Rx plus nucleophile like that, and here nucleophile is replaced at our halide. What they ask in the decreasing order of the rate of the above reaction with nucleophile. Okay, so you have to find out the nucleophilicity or nucleophile uh, strength order. Okay, which nucleophile is better, that way you have to find out. Okay, in decreasing order. This is what phenoxide. Now in case of phenoxide, that O negative is doing resonance. Okay, phenoxide is nothing but this one, and this one is keep doing resonance, and due to that it's not that good nucleophile. Okay, if that charge is unstable at that time, they are more better nucleophile rather than it is stable. Okay, if it is stable or it keep doing resonance, the nucleophilicity is keep decreasing. Okay, what is this acetate? Acetate means what? CH3 C double bond O minus. Okay, now you can see here this is more better. What to say? Stability is more. Okay, you have to find out basically stability order and which one is more stable, that one is least nucleophile. Or okay, that way you can say this one is stable compared to this one, it is more stable. And what about this negative charge is localized. Okay, it has no place to do the delocalization. It is localized. Since it is localized, it is more unstable means it is more better nucleophile. So C is the best one. I am writing here C is the best one, and after that A and B both has the ability to do the delocalization. Okay, but here negative charge from oxygen coming to carbon, which is not that good. Okay, but here because negative charge always want to be with atom which are more electronegative, but here it is equivalent resonance. Oxygen negative is going to another oxygen. Okay, so C is the most strong nucleophile here. After that A will come, C, A, and after that at last B will come. B is not a good nucleophile at all here. Okay, now another way I am telling you, even though that's not first of all you should know that this conjugate base form stability order, that is the best thing. But even you are not able to find out or you are getting confusion, so sometimes you can do one thing. Whatever nucleophile they have given, you just add one proton with them and try to make their acidity order. Okay, this is phenol, this will be acetic acid, and this will be water. Yes, now you know that among all of these, which one is the strongest acid? Acetic acid. Acetic acid pK is around 4.8. This is the strongest one. Then phenol pK is around 10. So this one first, this one second, and then water. Water is to be honest, the exact pK correct one is 14, but in book they are writing 15.7 something like that. Anyway, so 1 2 3, so you are getting this one is strongest acid. And one thing you remember, strongest acid, after removing the proton you will get the weakest base. Okay, this way whenever if they ask basicity order, you can easily find out this way, and that is the only good way to do in case of basicity. You have to add the proton and you have to find out the acidity order and make the reverse. But in case of nucleophilicity, because always basicity and nucleophilicity is not equal, is not same thing, but still many times you can find out. Here it is working, so here also you can find out. This is the strongest acid, so weakest base, weakest nucleophile. B here, this is the weakest acid, so it will produce the conjugate base as a strongest base or strongest nucleophile. Hope you understand. I have said the both way, but stability of that particular nucleophile, knowing that is better. Okay, anyway, I have done this first one. Now we'll go for this one. At last we will come to here. Okay, now come to here. Which of the following cannot be A? Okay, they have given A and they are saying if which one is not A, HBr, they will keep this product. Let's see one by one. First I have to see it's recording or not. Yes, everything okay. So if I do this one with H-bear means what? Marconi coefficient. Where I will get carbocation? I will get carbocation here. Okay, here, and this one I will get as CH3. Now 5-membered ring, next carbon is carbocation, so it will convert it to 6-membered ring. Okay, it will go to 6-membered ring and CH3. Okay, once it will go to 6-membered ring and CH3, that ring carbon you will get carbocation here, and now it can do the 1,2 hydrate shift and it will come to here. Once it will come to here, again it will from here it will shift to this tertiary carbocation, and here Br will come, so you will get this product. Here Br will come, so you will get this product. So this can be our A. Okay, so first of all, here double one is absolutely okay. If they keep like this, it can be okay. So A cannot be our answer. Which one cannot be, they are asking. Okay, so let's go for B. Yes, if we do the carbocation producing, we will produce in carbocation this particular carbon. Yes, here also Br can come. So this is also possible. This is also possible. If I go for this one, again carbocation, this 3° one is more stable. This is also possible. But what about this? Here you can see, if I produce carbocation here, I will get carbocation in this place. Now in this place Br will directly come and it will produce, because since ring carbon itself has positive charge, so there is no ring expansion, nothing. Bromine will directly come and you will get this product, but this product is different, so you are not going to get that. Okay, so this is not possible and they are saying cannot, so this is your correct answer. Okay, got it. Now come to here, you can take a screenshot. I will drop this one. Let's discuss this question. Which of the following is most reactive towards nucleophilic substitution reaction? First of all, once you see everywhere benzene is there, benzene is not showing good nucleophilic substitution reaction. They will show nucleophilic substitution reaction once there will be a good electron withdrawing group in ortho or para. Okay, so in para position everywhere nitro is there, so yes, it can show. Okay, now you may thinking here fluorine is there, here chlorine, here bromine, here iodine. We know that in case of substitution reaction, nucleophilic substitution reaction, iodine is very good. Okay, but that is when it is normal Rx. Okay, like R, F, Rs, I. Now it is, this one is very good because iodide is very good leaving group and it is very easy to break the bond between carbon and iodine. Okay, but in this case you have to understand one thing. Here they are going to show the mechanism of SNAR, and in case of SNAR, carbanion intermediate is carbanion, and that carbanion stability you have to find out. What I am trying to mean, if nucleophile is coming, nucleophile will attack here, definitely carbon cannot make 5 bond, this will shift to here. Okay, this negative charge will shift to next carbon. Okay, so you will get here, suppose I am drawing here, nitro is there everywhere, para position, this is fixed. Now I have fluorine here, and once nucleophile will attack this carbon, NO2, this one will shift to here. So what you will get? You will get as intermediate this one negative, here fluorine, here NO2, not NO2, nucleophile. This is nucleophile. We don't know whatever nucleophile it is. Now in this form, this carbanion stability you have to see. Now you imagine here fluorine, chlorine, bromine, iodine, all 4 can be. Now in this case, which one this negative charge is most stable? Only in case of fluorine, because here only inductive can take place, because it is sp3 carbon, so we cannot assume about mesomeric effect or resonance or anything. We have to only imagine about minus I. Fluorine has the strongest minus I, that's why this negative charge is the most stable in this case, and that is the reason in this case A is your correct answer. Whoever is thinking iodine will be the correct answer, no. In case of SNAR, you have to go with fluorine one. Okay. Otherwise, mostly nucleophilic substitution reaction other than SNAR, you can easily go for iodine one whenever they will compare with the halogen. Okay. Hope you got it. In this case, you always remember you have to find out the stability order of this particular carbanion. Where is the most stable, that will be the fastest one who will show the reaction. Hope you got it. Thank you for watching, and do share with your friends so that I can make more and more videos.